Hermans here, Supply Chain Dynamics, Chapter 8, Sysdea Gameplay 2, the flows of tooling and production. So the next two stages in our aerospace supply chain after basic design and detailed design are tooling and production. When an aircraft is being taken into production, that's usually something that takes 10, 15, 20 years. All the time the parts of the aircraft are manufactured by specialized tools, and the design and manufacturing of those tools is an industry in itself. Anyway, you can only design and develop and manufacture those tools as soon as you know what parts they are to manufacture basically. So tooling follows after design, not completely. In this case, the required completeness of the design is around 50%. So when 50% of the detailed design is completed, you can start with the tools. After all, perhaps half of the design is already clear, so you can start working on it already. The logic is the same as in detailed design. So we have 1,000 tools to be developed up here, and they only start flowing into the next stage of tooling into development as soon as this tooling starts. And the tooling starts if the completeness, at the point when the completeness of the detailed design has passed the threshold of the required completeness. And based on historical estimates, that was put here at 50%. Then rather quickly, as you can see from the graph, rather quickly those are taken into production, and then it takes quite some time periods to complete them. How productive this tooling completion rate is depends on, similar to the earlier stages, a number of things. Well, there is a material delay in here, tooling in development divided production delay, but usually the real constraint is the feasible tooling rate. And the feasible tooling rate depends on the one hand, the tool development capacity that we have today, and on the other hand, we don't have quality in this case. In this stage, we don't have a quality that affects that. That's what happens up here in the tooling rate. And then tooling is completed to a certain extent. The completeness of the tooling is then input for the next stage. What we do have is a number of flaws in tooling, the undetected tooling flaws, and this is also similar to the earlier ones. We start off with a certain number, say 1,000 tooling flaws, and as we find more flaws in both the tooling stage as well as in the next stage of proto production, the tooling quality goes up and affects also other parts of the model. So that's tooling. From tooling we move to production, and here production, we have the production starts and we have the production work in progress. Production starts also take quite some time. And how many do we start? We start as many as we have in the customer order backlog, which you'll see next. This production then takes place. The shape of the production is a more complex formula. That's a third order delay, which is detailed out here. Basically because Sysdea doesn't have a standard function for that, but so you can also nicely see that that follows an S-shaped curve. So when you start the first orders, they will a few of them will only pass, then quite a lot of them, and then there's a tail towards the end. This third order, which is basically this development time, is transferred in here in the feasible manufacturing rate, and that determines how fast we produce. What we have, the aircraft produced for the first, in this case 40 aircraft, we are still in the phase of the proto production. This is the phase in which the The Dutch saying is kinderziekten, children diseases, but teething problems is probably more appropriate. The problems that are still inherent to the design and the tooling can be discovered here and can be fed back into the earlier stages of both tooling and detailed design. Manufacturing capacity is also started as soon as we have manufacturing capacity required. And manufacturing capacity required, we don't have those factories ready all the time. We have them ready as soon as they can produce, which is around the time of the scheduled first delivery. We'll see that in the order flow next. Adjusted for the fact that it takes time to adjust capacity and adjusted also for the production cycle time. So the manufacturing capacity required also depends on this production cycle time. As soon as deliveries to customers come into site, manufacturing capacity is built, and that capacity then also leads to this feasible manufacturing. So that's the logic up here in production flows.